Intermediate Algebra for Statistics, Simplifying Radical Expressions. Lesson objective: use the product property for square roots to simplify radicals. Lesson objective: principal square roots. So far we have worked with polynomial expressions. In this video we will work with a new type of expressions called radical expressions. Working with radicals will be necessary for future sections involving quadratic equations. What number squared is equal to 25? If you think about it, there are two. -5 and 5. -5 times -5 is 25, and 5 times 5 is 25. So we say that -5 and 5 are square roots of 25. A square root of a number a is the number we square to get a. Of the square roots of 25, only the non-negative square root 5 is the principal square root of 25. In symbols, we write this symbol, which is read square root. So this is the square root of 25, and that equals 5. Definition: if a is a non-negative number, then the square root of a is the non-negative number we square to get a. We call square root of a the principal square root of a. Here's some examples. Square root of 36 is 6. Square root of 81 is 9. And square root of 225 is 15. So what this is telling us is if I take this number and square it, I get 36. What number squared will give me 81? The answer is 9. 15 squared is 225. Definitions: the symbol that we use for square root is called a radical sign. An expression under a radical sign is called a radicand. For the square root of 2x plus 5, the radicand is 2x plus 5. A radical sign together with a radicand is called a radical. So these two together make what's called a radical. An expression that contains a radical is called a radical expression. Here are some radical expressions: square root of 5, square root of x, square root of 2x minus 5, 4 times the square root of x plus 8 minus 8x, 3 times square root of x minus 2, all multiplied by the quantity square root of x plus 7. Is the square root of a negative number a real number? Consider the square root of -16. Note that the square root of -16 does not equal -4 because -4 squared is equal to a positive 16, not a negative 16. Since any number squared is non-negative, we see that the square root of a -16 is not a real number. In general, a square root of a negative number is not a real number. Example 1. Find the square root. Number 1, square root 49. Number 2, square root of -49. Number 3, negative square root of 49. And number 4, negative square root of a -49. Solution: square root of 49 is 7 because 7 squared is 49. Number 2, square root of -49 is not a real number because the radicand is -49. We cannot take the square root of a negative number. Number 3, negative square root of 49 is -7. We can think of this negative being on the outside as a -1, so we compute the square root of 49 and then we multiply that answer by a -1. And number 4, negative square root of -49 is not a real number because the radicand is negative. Rational and irrational square roots. A rational number is a number that can be written in the form a divided by b, where a and b are integers and b is not 0. A perfect square is a number which has a square root that is rational. For example, 36 is a perfect square because square root of 36 equals 6, because 6 squared is 36, and 6 can be written as 6 over 1, where a would be equal to 6 and b is equal to 1. So 6 over 1 is what we call a rational number. By squaring the integers from 0 to 15, we can find the integer perfect squares between 0 and 225. So this will be on the next slide. So if we take the integers from 0 to 15 and square each of these, we get this list of perfect squares. It's probably going to be a very good idea for you to memorize the perfect squares from 1 to 10. You'll be using these perfect squares a lot in the future. For a number that's not a perfect square, the square root of that number is not a rational number. This type of number is called an irrational number. For example, square root of 10 is irrational. We know that the square root of 10 is between 3 and 4 because 3 squared is 9 and 4 squared 16, and 10 is in between 9 and 16. To use a calculator to get the estimate for the square root of 10, we hit second and then our x squared key, and we see square root of 10 is approximately equal to 3.16227766, and technically irrational numbers in decimal form go on forever. Example 2. State whether the square root is rational or irrational. If the square root is rational, find the exact value. If the square root is irrational, estimate its value by rounding to the second decimal place. So number 1, we have the square root of 625. Number 2, we have the square root of 21. Number 3, we have the square root of 149. And number 4 is the square root of 361. Solution? So if we use our graphing calculator, find the square root of 625, hit enter, we get an output of 25. So this is rational. 625 is what we call a perfect square. Number 2, square root of 21 is approximately equal to 4.58. This is an irrational number. Number 3, square root of 149 is approximately equal to 12.21. And again, this is an irrational number. And the last one, square root of 361 equals 19. This is a rational number. 361 is a perfect square. Thanks for watching.